Hi, everyone. So I'll just advance the slides a bit here. So building on what Ray just presented, I'm going to get into the SPAT challenge model, concept operations, and requirements document. When we were meeting with the SPAT resource team about 8 to 9 months ago, we decided that one valuable resource for all of you deploying and accepting the SPAT challenge might be to have a model, concept of operations, and requirement document to get yourself started as you start a system engineering process. So the 4 things I'd like to do today on this presentation is I want to introduce you to the 2 documents, the model ConOps and the model requirements, which are, as Blaine mentioned, on the Center of Excellence website. You can download them and use them if there's any value. I want to define the term SPAT Infrastructure System because we use that throughout the document, and I want to just kind of be clear about why we did that and how you might tailor that to your local preference. Then I want to describe the approach we took in developing the document and then share a few examples from them just to kind of help you understand how they might play a role in your deployment. So the model documents, as I said, there's 2 standalone documents. We originally were going to do them as one, but as they got to become rather large, we decided we'd split them into 2 documents. They're available online. They're really developed to help you plan for your SPAT deployment. As Ray mentioned, we really hope that those agencies that accept the SPAT challenge do it with the intent of ongoing operations for a long time. We wrote these so that they could hopefully be adapted to your local site, your local conditions. They're really intended to be a model. We've identified them as working drafts to serve as resources to you. They're not prescriptive in any way, and we don't know as though we'd ever advance them beyond working drafts. We've had them reviewed by several committees, several groups, and what we've asked them to do is we've asked them to point out anything that's incorrect, because we certainly want to correct that, to point out anything that we should add to these, because we'd like to add more information if it would benefit it. We really haven't asked for feedback on kind of the structure of the documents, because we really just see it as you're going to prepare your documents how they suit you best. So this is really just a reference for you to use. So it might always stay as a working draft, but it's really just intended to be a resource for all of you. So the next thing I want to do now is define the term SPAT Infrastructure System, and I'll do this with a couple of diagrams. So if you look at this diagram, starting on the left, you have your sources of SPAT data, and those could be the traffic signal systems, the most likely one. From a general standpoint, it could be either the traffic signal controllers on the roadside, or it could be your central signal control software. Specific to the SPAT challenge, it really calls it out as the traffic signal controllers on the roadside. But regardless of that, there is the source of SPAT data. And then on the right side, there's the users who will benefit from the SPAT data. And we've identified drivers and pedestrians. We could probably put in there driverless cars, driverless vehicles, but in a way that's also represented by the driver. But those are really those who will benefit from it. And in order to do that, there's a thing that sits in the middle called the SPAT-enabled connected vehicle systems. And that's where we get into 2 things we want to define. One of them being the SPAT Infrastructure System, and that is what's the focus of our ConOps document, the way we wrote it. It's new infrastructure that would securely communicate SPAT, map, and supporting data to the vehicles and pedestrian devices, and it may also receive data from the vehicles and pedestrian devices. There's a third element that also fits in the middle here, which is a direct user of the SPAT Infrastructure System, and it's the SPAT vehicle systems, which are those applications that will be installed on passenger or fleet vehicles. They'll communicate with the SPAT Infrastructure System to receive the data, and then they'll use that to support the driver safety and mobility. There's a second one, which is personal information devices. So these would be things that the handheld devices that would receive communications from the infrastructure and support pedestrians. So we use this to kind of illustrate that the SPAT Infrastructure System doesn't directly connect to the drivers or the pedestrians. They're not the direct users of it. There is this user in the middle, which is either the vehicle system or the personal information device. And that's really the direct user of the SPAT Infrastructure System. So in this ConOps, we don't go into how those applications might work. We don't go into what they would do. That would be up to whoever builds those applications, whether it be an automobile manufacturer or an aftermarket provider or something like that. What we do talk about is we do talk about the needs of the users, the drivers and the pedestrians, and we do talk about what the SPAT vehicle system and the personal information devices would need to satisfy those needs, and how the SPAT Infrastructure System needs to provide that. So as you read the documents, you'll see SPAT Infrastructure System throughout it, and I hope that kind of helps introduce why we call it that. You notice in Ray's context, he had the CC system, the Connected Corridor System. That would include the SPAT Infrastructure System as part of it, but it would also include other things that might be associated with that. We recognize you will likely call it something different. You maybe already do call it something different, but we've just used the generic term of SPAT infrastructure system, really to draw the boundary around what is the focus of the ConOps and what's outside of that focus. So the next thing I want to do is with building on that is just talk a bit about the model ConOps. So again, it's focused on the SPAT infrastructure system. The indirect stakeholders are the pedestrians and the drivers. The direct stakeholders are, as I just mentioned, two of them, SPAT vehicle system and pedestrian personal information devices. But then there's a number of other direct stakeholders, like the traffic signal system itself, the traffic data system, that data might be received by the SPAT infrastructure system and sent to the traffic data system. There's a security backend, there's traffic engineering staff, there's maintenance staff. So we really wanted to, in the model ConOps, we wanted to represent some ideas and some concepts for how maintenance of the devices might occur, how operations of the devices might occur, how configuration of the devices might occur, just to provide some help in getting everyone started with thinking through those operational procedures. All of what I've just described, as Ray also mentioned, is based on applications too. So we do describe some applications in here. If you notice, there's two blue boxes here. The blue boxes at the top are those applications that utilize SPAT. So it's got things like red light violation warning, pedestrians in signalized crosswalk, equal arrival departure, also called traffic optimization for signalized corridors. And then there's a personal device, which is mobile accessible pedestrian signal system, PEDSIG. All of those need SPAT data in some way. The blue box down below are other applications that may need SPAT data based on the local deployment, or they may be useful to deploy simultaneous. So signal priority, emergency vehicle preemption, probe-enabled traffic monitoring. The ConOps focuses on the four applications described in the top box. Red light violation is the emphasis of it, because when we first talked about this with the group of OEMs, they said they would like to work the SPAT challenge towards red light violation warning and test towards what's needed for that. So you'll see an emphasis on red light violation warning, but we really do step through the needs of the other three applications and trace those through with the concepts. So our hope with this is that as you sit down and plan your deployment, as Ray had done in Minnesota, when you think about the applications you might want to support, if you decide to support one of them or two of them, you might be able to pull stuff out of the ConOps that benefits you. If you decide at this point we're not going to do equal arrival departure, you can just ignore all those parts of the ConOps. And you find a lot of stuff is italics that is optional stuff that's easy to ignore. So what I've just stepped through is really section one of the ConOps. It kind of introduces it, it draws the boundaries around what's in the ConOps and establishes the system. And then we have a section two which gets into situation and needs. Again, these are written to be model, so we define needs for the stakeholders, and that includes the indirect users, the users, and the other stakeholders. So those needs, I'm just giving an example table down there. Looks much like Ray's. There's a challenge. So in this case, we identify the challenge related to red light violation warning with the average of 700 fatalities a year, 90,000 injuries. And then you see over there's the need, which is drivers need a red light violation warning to help them avoid unintended red light violations. As you see, it's numbered. So it's very standard. Those of you that have done these, it probably looks very familiar. But section two really focuses on defining the needs of all the stakeholders. Then as we get into section three, that's where we define the operational concept for how the SPAT infrastructure system would support the other systems in satisfying those needs. So it's how each user will interact with the SPAT infrastructure system. And remember, users include humans and systems. And again, these are written as numbered lines for traceability back to the requirements, or from the requirements. So I gave you an example down below. As Ray pointed out, the idea is to kind of describe how the other systems will interface with or will use it. So this is an example here. We write a number of operational concepts from the SPAT vehicle system's perspective. So it shows you how it describes the SPAT vehicle system will receive current signal phase and timing from the SPAT infrastructure system for approaching intersections. And then it has the needs that maps back to. And then the subsequent numbered ones down below it go into more detail. You can see where that's describing it beginning at a distance to enable the SPAT vehicle to perform needed calculations and information display to drivers, and that's a different need. So again, numbered lines at the operational concept, so 3311, and then referring back to numbered needs is how we kind of organize the whole overall operational concept for the various components. Then there's a section 4 on the operational concept for SPAT, map, and traffic data. And this is where we get into the details about the use of J2735, SPAT and map messages, as well as details about the traffic controller data. And our goal here was an attempt to get as much of the information describing this data exchange it into one document as possible. And as I said, we're open to adding more if we need to. We're open to any corrections with it. But this is hopefully a lot of information that will really explain the way all those messages work together. And then section 5 is the operational scenario. You saw Ray gave some examples of what they've done in Minnesota. We presented kind of a model sequence of events, chronological description of how vehicles will interact with the SPAT infrastructure system as they go through it, so you can read those. We thought about in future versions adding some more scenarios, scenarios such as what happens when an intersection broadcasting SPAT is under construction and the lanes through it are being directed by flaggers. Do you turn off the SPAT broadcast? Do you go in and tailor the map message for it? It probably depends upon how long the construction goes on, but those are some of the examples of scenarios that really can be talked through with both the IOOs and the OEMs to understand how they might be addressed. So that kind of wraps up my overview of some examples from the ConOps. I just wanted to talk a bit about the requirements. So Ray gave a good introduction to what those are. We really set out to define minimum requirements to maintain compatibility between the broadcast SPAT message and the vehicles on board units that are planned to be deployed. I want to show a few slides which kind of step through how we organize those. And much like some of Ray's, I realize that these slides may be a little bit hard to read here, but this is a diagram that's in the requirements document. It is a functional diagram, so it describes functions, not a flow diagram. It's not intended to show how data flows or anything like that. But we've organized the functions into a series of groups. So we have groups, we have a number of groups in here, and I'll step through a couple of those if I highlight on the next slide. So managed SPAT is one of the groups. So up there you can see the red circle. We have two that are bold. The bold ones represent those that are needed, are required for a minimum SPAT deployment to meet reduced red light violation warning. So just an example, there's a high-level function which is to assemble the current needed, or assemble the content needed for standard SPAT messages. There is another function for assemble SPAT messages that conform to the SAE J2735 standard message format. And then there's a third function which is not bolded, so it would be more of an optional one, which is to assemble SPAT messages that comply with other standardized message formats. So we recognize, much like with Minnesota's deployment, that you might use other message disseminations to the vehicles. So we leave placeholders in there for where you could go in and enter your additional details about each of those. I won't go into a lot of detail about these, but I just wanted to highlight a couple of the other ones. So group 4 is functions related to managing the maps. So in there we have 5 of them, 4 of them which are required. Manage the map database, manage the map dynamic features, assemble the content needed for the map message, and then assemble the map message that conforms to the SAE J2735 standard message format. And again, we have an optional one, which is assemble other standard map messages if you're disseminating it using other communications mediums. So you can see how each of these are high-level functions, and when you read into them, you'll get into much more detailed functional requirements describing each of those. This one is the managed SPAT vehicle system interface. Here's where it includes 2 required ones for the SPAT challenge: broadcast 5.9 gigahertz DSRC messages and receive and process 5.9 gigahertz DSRC messages. Then we recognize that there's alternate communications mediums. So we have a couple other ones, which is publish the data over alternate communications and receive the data over alternate communications mediums. The last one I'll point out, just to kind of draw your attention to it, is Group 12 provides support. We only have 2 that are identified as mandatory in there, but we have a lot of option ones. This is where we wanted to point out things that you might want to consider in terms of operating your system for the long haul. Things like how do you configure messages? How do you manage the data? How do you manage reports? How do you manage alert diagnostics? How do you reset the system? How do you configure the system? Things like that. So we go into some requirements for each of those for you to consider as well. So I have a slide which shows an example of a requirement. Again, Ray showed some of those as well, but here's one in Group 2, Managed SPAT. That's requirements that are describing the functions of SPAT infrastructure to assemble the SPAT data into the standard SPAT message. As you can see, the one down there gets into process the SPAT infrastructure system shall process the message containing SPAT data obtained from the traffic signal system and generate a SPAT message. And you can see that requirements numbered, as well as there's a number in the far right column, which maps back to the operational concepts that I showed you, and those map back to the needs. So as Ray said, if you read through these requirements and you wonder why they're a requirement, you can trace it back to the operational concept and trace that back to the need. And that's a good exercise to follow. So again, we came up with these. We recognize that these would just be a starting point for you, or maybe something you've already developed requirements and you want to just verify them with this. But we know these won't be something that can just be dropped in and used by any of you, but again, we're hoping this is really just a resource to encourage the overall systems engineering approach you might take. I did want to just mention, in the requirements, there's the column that identifies it as minimum or optional. We have 4 categories of those. The minimum is those that are necessary to achieve a minimum SPAT broadcast to support red light violation warning. That was kind of the agreed application we would build around the SPAT challenge, at least as we had to sit down and develop requirements. Optional are those requirements that are used to receive alternate approaches. So it might be a different message format, it might be a different communications mechanism if you're not using a DSRC or things like that. Those are optional requirements just mentioned in there. And then we have other optional. We have optional, which is a minimum for application. So we've identified several requirements that if you decide to do an application, say for example you want to do priority preemption, these would be a minimum application you would need for that. It's optional in the sense that the definition of the SPAT challenge is just to deploy the minimum stuff for red light violation warning, but it would be minimum if you decide to do those other ones, because we just wanted to call out what those were. And then flip side of that is we have optional recommended. So these are really those things that are optional, but we're recommending them more for systems manageability. It gets into things like reporting, logs of the system, user management tools. So we talked with some of those agencies that have deployed this and we're operating it and capture requirements that they would have for an ideal system. So again, you certainly don't need those, but they're recommended for you to consider them as they might support your system manageability. And I believe I have one more slide before I turn it back over to Blaine. In that slide, I really just want to talk a bit about the verification of this. So when Blaine showed the SPAT challenge map, and you saw that there's those sites that are under development in green, those sites that are developed in blue, the question came up from a discussion with OEMs about how do we know that those that are completed are meeting all the requirements, and that if a vehicle with an application on it, let's say it's red light violation warning, drives up to that, how do we know that the two will sync and will talk to each other? That's really the challenge we're getting into with connected vehicles. In the past, the DOTs, the infrastructure owners and operators, build the roads that the cars drive on, and they deploy signs that the drivers see, they deploy traffic signals that the drivers see, but that handshake to the vehicle is really very much new with this. So we dove into this problem, and there's a document that's on the Transportation Office of the National Operations Center of Excellence website, the SPAT Challenge website, which is the SPAT Challenge verification document. So it was developed by CAMP, Crash Avoidance Metrics Partnership. It's intended to ensure that there is compatibility between your SPAT deployment and the minimum requirements for onboard applications. And it's written around red light violation warning applications, so you can do that. So the idea is that document can be used, and as we progress through this, eventually those pinpoints, those push pins on the SPAT Challenge map could turn gold, those that have been verified or something to that effect, and we can begin to understand which ones have gone through a verification process and a testing process. There's going to be much more on this topic during webinar 5, which I think is actually webinar 6 now with the extra map message demonstration that was added, but we're going to have presenters from CAMP present that document. We're also going to be able to hear from at least one site which has used the document to verify their SPAT deployment, possibly a second one. So we expect to go into a lot more detail there, but I just wanted to mention at this point so you see that there is kind of the flip side, which is verifying that these deployments do work with any number of vehicles that might approach the intersection. And